And now it's another episode of AWS Howdy Partner. Take it away, Braden.
Hey, everybody. Hopefully everyone's had a great weekend. Welcome back to Howdy Partner, where we highlight AWS Partner Network partners. Episodes are hosted by AWS Partner Solutions Architects, such as myself. And today, we are joined by MongoDB, Aaron and Andrew, and of course, our new co-host here, Rob. Why don't we all go give a round of introduction real quick? We'll start with Aaron, hit Andrew, and then we'll go with Rob next.
Sure. Yeah, thanks for having me on today. So as you heard there, I'm a developer advocate with MongoDB. Been with the company, well, since kind of like the new year. So still kind of find my feet a little bit, but hopefully we'll get some fun stuff. I'm on the Realm team, which is like our serverless platform and on-device database and stuff. So we're looking a bit at that today. And yeah, really looking forward to the stream.
Yeah, so I'm Andrew. I've been with MongoDB for about 5.5 years, and I'm based in the UK, so it's just past 10 p.m. here. Ooh. So I've got here.
Thank you very much for joining us.
Good to be here. So so I work in a team where we actually build applications on top of MongoDB products. So I'm an engineer, but I don't work on the MongoDB products themselves, but like I say, reference applications that use them.
Great.
Hi, everyone. Hope you had a good weekend. Great to be on this first Howdy Partner. My first Howdy Partner. My name is Rob Malka, colleague of Braden and AM. We're solutions architects helping partners through their partner journey.
Awesome. Great. Well, we have a lot of great contents prepared for you all. So what we'll go ahead and do is we're going to kick it off to Rob, who has a nice introduction of MongoDB and a couple other topics that will help lead into Aaron and Andrew's demo today. So Rob, why don't you go ahead and take it away?
Okay, thanks, Braden. So before we get into MongoDB, Andrew and Aaron will do a great service on that. But essentially, we want to start to ask ourselves, what is streaming data? Why streaming data is the question we get a lot of the times. And I guess one way to think about it is thinking of it like a continuous flow. And if you could make it into an analogy, I'm thinking a stream, like an actual stream of water, implying that there's rushing water. And in general, streaming, all of us are pretty familiar with streaming online. We've produced live streams, so we understand what's going on there. So you could substitute pixels essentially for rows, and then that's essentially what streaming data is. So the key in data streaming is garnering insights that arise as the data is streamed. And imagine you're trying to catch a fish. You're chasing a fish down a river versus putting a net near your boat to catch a bunch of fish. So with streaming data, what would be that net? And in that, you could have Amazon Kinesis or Kafka or any other data streaming solutions available out there. And with Amazon Kinesis, this is a scalable and durable real-time data streaming service that continuously captures gigabit of data per second from hundreds of thousands of sources. So think of Kinesis data streams as it's made up of shards, and a shard is a uniquely identified sequence of data records in a stream. So a stream is composed of more than one shard, and basically depends on your use case that you leverage more shards. So with the types of examples for streaming that we want to think of, like real-time analytics use cases, we've got milliseconds, seconds, and minutes. For milliseconds, we're thinking messaging between microservices, response analytics. Seconds, we're thinking of log ingestion, IoT device maintenance. And then minutes, we're talking about streaming ETL into data lakes and data warehouses. So let's go into a small demo of how we would set up an ingestion of data into a Kinesis data stream. And I will be sharing my screen now. So as you can see here, my terminal window is open. I'm skipping a few steps here, but essentially I launched an EC2 instance with a pre-installed Kinesis replay snapshot. And essentially in this EC2 instance, what I'll be doing is collecting historic New York taxi trips at a specific rate into a Kinesis data stream. The application reads the timestamp attribute of the stored events and then replays them as if they occurred in real time. So this application is running on EC2, and it's running a Flink application to replay it into Kinesis. So what that looks like, the command I'll be using here is java jar, and there's the jar file right here, Amazon Kinesis replay. And then I've got a streaming region of US West 2, that's my closest region, with a 1800 second or 13 minute stream. So my stream in Amazon Kinesis is labeled initials taxi trips. And this is part of our Amazon Kinesis workshop lab. And this is available online. I'll drop a link in the chat window. All right, so I've got a stream set up, and creating a stream is pretty simple. What we're looking for is adding a stream name, and then the number of shards, minimum of 1, and a maximum of 492 with an account limit of 5,000. So you can always reshard. Resharding is basically when you want to split or merge shards, and that can be done as needed. So
question there, Rob, when you split or you merge, is that to help manage the demand? Say that you don't need as many shards, so by merging that, you've reduced costs because you now have an expected reduced demand. Is that what that is for?
That is correct, and that is basically resharding is performed on a need basis. So for your Kinesis data stream, in terms of cost, there is definitely, it is pretty, there's some pricing examples on the Kinesis page, but one of the key aspects of resharding is to get better performance as well.
Awesome.
Yeah. So yeah, I've got a data stream up and running. So what I'm going to be doing is running this command against that stream. So now I'm streaming, well, getting an error. Let me see. But yeah, how labs work in real life, right? But
it's always a problem on Twitch.
Yeah. So we've got a stream up and running. And again, I want to mention what producers are and what consumers are. And in this case, what I have on the EC2 instance is a producer, which puts records into the Kinesis data stream, and then consumers, which would be what you leverage to, add on top of that consumed data. And in this case, you can use Kinesis Data Analytics, which is a Kinesis offering, or Kinesis Data Firehouse, which reduces the need to manage a lot of the streaming. And then you have just a ton of options here. And let me just see what is going on here. Got a few commands. Okay, so yeah, that did not work. So essentially what happens is I would be streaming data. And then in terms of what we see in the stream metrics monitoring page, you're looking to see what records were put. And I believe I tested this a day ago. So you can see the records, the various records. There's the sum. And you can see that a lot of data was received in just a short amount of time. But yeah, once you receive this data, creating an analytics application is what you want to do. And in this case, we would just create a application using the SQL runtime, which is pretty easy and straightforward to use. And then we connect a stream and this existing stream. And then we can leave everything else to default. And then typically what we want to do is discover the schema to see if there are any modifications we want to make to the actual schema. And then once that's done, you can save and process your analytics. So that's to sum up, like Amazon Kinesis is very robust in its offering and works with various data sources. And we've got a huge integration with MongoDB, which Aaron and Andrew will get into shortly. Braden?
Yeah, perfect. So AM, if you want to take Rob off there, and perfect. So we're going to go ahead and jump in with Aaron and Andrew. Before they get started, I just want to remind everyone that this is Howdy Partner, and our goal is to be able to enable viewers like you to be able to learn what partners have done on AWS or with the AWS. And so with that, Aaron and Andrew have prepared something very special for us today. And so we're going to go ahead and kick it off to them. Aaron, Andrew, welcome. And what do you have for us today?
Yeah, thanks again, Braden. So I'll kind of go through like the setup of Atlas and stuff in a moment. Mostly what I'm walking through is kind of using MongoDB as both an input and a destination for Kinesis. So it's going to be that data source that like Rob was talking about using the taxi data, but it can also be an output. So if you've got data coming in from multiple different sources in the Kinesis, you've got that fire hose of data coming through, you can then send it off to MongoDB, store it in your Atlas cluster, and then you can start using like our aggregation pipeline to start drilling down through that data, generate different views out of it, whatever you want to do with that data once it's in there. I did a article recently on basically this whole flow, so I made a little mock kind of weather station out of a Raspberry Pi, with temperature sensors and that kind of thing, that was writing the data into an Atlas cluster using Python, which was then getting picked up and sent for Kinesis, and then back again into MongoDB. So doing that full kind of circle round. I'm not sure maybe you can remind me what the commands are to view like links and things in chat. Oh, I think you're mute. Braden, I'm not getting any audio.
Sorry about that. Yes, I will drop those links in so that they can see exactly what post you were talking about there.
Thank you. Yeah, so I'll walk through kind of if there's anything you think I'm going through too fast on today's stream, or you just want to check it out later, that post will go through everything as well for folks. So, but I'll just start sharing my screen now so we can have a look at some of the Atlas setup. Okay, so what I'm looking at the moment then on my screen, you should be able to see the kind of Atlas dashboard. So I've got a project set up already here for Realm Kinesis, but I'm just going to create a new project, just like take us right way back to the start. So let's create like AWS stream, my project name. Oh, searching my existing projects. Here we go. AWS stream. Okay, I'm just going to leave myself as the only member in this project for now. Okay, so a new project created. I don't have any clusters at the moment. Now, because we're going to be using Realm, which is MongoDB's kind of like serverless, like cloud-based offering, this is one thing that won't work with like our community edition. So people think of MongoDB, they probably think of the open source community edition of the database or a server they can download and run themselves. And that's only kind of part of what we offer. The other part is Atlas, which is our fully managed cloud database offering. Realm allows us to create like Realm apps and Realm functions and authentication and roles and everything else that expects to be connected to an Atlas cluster. So in order to use Realm, you're going to have to use Atlas rather than like your own kind of community edition of MongoDB. So I'm just going to create a new cluster of that. I can pick like my organization project is going to be JavaScript. Let's just continue. And here we get like to what kind of cluster I want. I'm just going to go for the free cluster. I don't need auto scaling or anything like that at the moment, so I'm just going to create a free one. I can pick where I want it to be. So I'm in Miami, so I'm going to go US East. That's close to me. Obviously going to go AWS. I can pick like my version of MongoDB. So I'm actually going to go 4.4. Let's go like cutting edge. I can turn on backups if I like upgrades. I can change the cluster name. I'm just going to leave everything else kind of standard here. But yeah, so I'm going to AWS, US East, etc. I'm going to create that cluster. So that's going to take a little minute to go off and do that for me. So essentially what's happening now in Atlas is it's going to create a MongoDB cluster. So it's actually going to create kind of 3 servers and set all those up for me and configure them all for me. This is only going to be like a small replica set of 3 nodes. There's no backups enabled. There's it's got limited. I can't bring the pricing up while doing this, but obviously it's got like kind of limited memory. It's a shared box, etc. Because I'm just running on the free tier. If I was to like upgrade to one of the upper tiers, and you get more choice of where you want to deploy it to. You also get like automatic backups, and you'll get additional kind of monitoring that you can use and other additional functions. But just purely for development and for giving us a try, I'm just going to stick with the free ones. It's going to take, as I said, a couple of minutes to run through and do all the deployments and stuff for me. So it's going to like, I'll tell you what, while that's doing that, I can switch back to the one I created earlier. And we can see it's like giving me kind of updates on what's going on here. So I think I have a Kinesis Realm one. Yeah, Realm Kinesis. Okay, so that's going to keep setting that up as I've changed cluster here. And what it's going to give me then once it's set up is, I can create my different collections. So I have, this one already has this kind of like reports. So as I mentioned before, I created a little like Raspberry Pi that was running as a pretend kind of weather station, so it had a couple of different sensors on it for detecting things like temperature and humidity and pressure. It also had an accelerometer on it, so I could detect if it was currently being moved, etc. And then this was just running a Python script that was just pulling this information, I think like multiple times per second, and then setting this up into my MongoDB collection on Atlas. And then once my new collection is deployed, I'll show you how we can then create a Realm app that is going to watch for any new updates to this collection. So anytime there's a new document, and send that into Kinesis. So let's see, how is this going on? 3 of 3 are deployed, so we're almost there. We really want to do this in kind of, I know I could have had it all set up before and, kind of here's what we prepared earlier, but I really wanted to show you kind of it going from very, very start. This is like creating a brand new replica set, deploying it into Atlas, how quick, or maybe people don't think it's that quick, but how quick it is to kind of get up and get running with all this stuff, really from like a brand new project. So
No worries.
that's hopefully going to finish in seconds. Yeah,
hopefully you don't run into any issues like I did.
While we waiting, Aaron, we have a nice comment here.
Sure.
I want to see if you agree. Too Slow to Draft has said MongoDB has the best socks at conferences. What is your statement on that?
See, I'm kind of, it's been an issue for me. I joined MongoDB in December of last year. So I work remotely anyway, but my job normally is to travel to all these conferences, give talks and run workshops and, talk to people in the booth and be that kind of like face in the community, and also help myself to whatever swag is on the stand, obviously. But there's not been any, for obvious reasons, there's not been any conferences this year. So my MongoDB swag game is fairly limited. Actually, they were very nice and shipped me a rather lovely developer relations hoodie.
Nice.
Yeah, so I can't be too mean about it. But I am missing getting out and gathering all the socks and the stickers and everything else from the conferences. Like, and obviously seeing people, that's kind of nice too. But my swag game has definitely gone down this year. I need to make up for it once we can start traveling again. Okay, cool. Yeah, so our cluster's been deployed. You see we don't have any collections or anything like that in it at the moment. I'm not going to worry about that. I'm just going to go and create a Realm app straight away. So Realm, as I mentioned, is like it's a lot of different things, to be honest. So there's the Realm Cloud, which is what we're going to be using to create these serverless functions. And you can trigger functions based upon like changes to your databases, or you can trigger them like on a frequency, like a cron job. You can trigger them for like any of the Realm SDKs. So like we've got a JavaScript SDK, so you can trigger Realm functions in the browser. But it also does this, like it has Realm Sync. In fact, let me just create the app. I think it's going to tell me a little bit about this what's in it. So I'm just going to call it like AWS Stream again. I'm just going to, so here's what I'm saying, it's linking to my data source. So this is the new Atlas cluster that I just created. So it's looking to link to that. I'm going to create my Realm application. And this is what I was kind of saying about it does a bunch of stuff. So nice, because it's a new app and it's the first time I've created one, it's given me like some additional kind of documentation. And the two things it's pointing out is we have Realm Sync. So Realm also has an on-device database, which has been designed for really using on on your mobile phones. So there's an iOS version, there's an Android version. We also are just getting ready to launch an Electron version. We have a Node version. We have one for Raspberry Pi, which is about to come out into kind of general release as well. And that database allows you to store information on a device and then have it automatically synced up to the cloud. So, and that will work like as the device goes offline as well. So if you lose your internet connection for whatever reason, once you come back online, it'll then resync all the data and it'll do things like automatic conflict resolution and stuff like that as well. And then GraphQL, for anyone who's not familiar with the graph query language, you can now stand up a GraphQL API in front of your MongoDB Atlas instances. So you don't need to really create like an API server or anything to access your data. You can just create you can just turn on the GraphQL service, and then that'll do it all for you. But we're not going to use either of those today. I'm just going to close this out. Instead, we're going to look at these functions and triggers. So I'm going to, first of all, just look at the fact we've got third-party services. So AWS is one of the third-party services we have. We've got things like Twilio and GitHub in here as well. For AWS, I'm just going to like give it a name. I'm just going to like leave these blank at the moment. Let's just fill in like rubbish data for those, because I'm just going to take you through the actual AWS setup in a moment. So I'm just going to create that service. Yeah, of course I should change my password. It's just 3 X's. And it's going to like, yeah, that's not normal password I would use, don't worry. And it's asked me to like to review and deploy. So it's telling me I've made changes to my Realm application, and do I want to deploy those? And we're like, yeah, okay, let's deploy those. Okay, it's deployed them for me. So I now have an AWS service that I can access from within my Realm functions. What I'm going to use that for is creating a trigger. So triggers can be like different types. You can have triggers that happen as it's scheduled. So essentially a cron job, so let's run this trigger once every minute or every hour or like 10 minutes past the hour, etc. You can have authentication triggers. So Realm also has support for users and roles. So authentication triggers, you can have something happen like every time a new user is created or every time somebody logs on or that kind of idea. And any of these will work with Kinesis as well. So I'm going to be using a database trigger just now, to show you like whenever you make an update to a MongoDB collection, then send that information to Kinesis. But it would work just as fine with authentication event too. So if you wanted to have like all of your authentication events, anytime you got a new user or a new login or a user decided to like delete their account, whatever it is, you could send that information to Kinesis and then have that passed on to whatever analytics service you want to use or wherever else you're like using as your destination for Kinesis. Like it's not just the database triggers that will work here. It's like any of these will work. So let's just like say we got AWS Stream is our trigger name. We're going to enable it. Event ordering, essentially that means like I want the request to be processed in the order that they occur. So with the database one, we've got like different types of operations. Some may complete faster than others. We can turn this off if we don't care about ensuring that the order of operations is followed. Like if we just want to like send every event, no matter when it occurs, off to Kinesis, we can just turn off event ordering and then it'll run them like in parallel rather than run them sequentially. Leave it on for now. We link it to our cluster. So I don't have any databases collected at the moment. So let's go back and do that first. So in my cluster I created here, so I don't have any data. I could load a sample data set. I'm just going to create my own. I'm going to give it a database name, which is like AWS and a collection name of stream reports. Let's create that. Okay, so I've got my collection and I've got my database. So I'm just going to pick it up, or if I'm going to refresh. Yeah, I'm going to refresh. Triggers again. So this stream collection. And then I can pick the operation type. So I can go, okay, this trigger should be run every time a document is inserted or updated or deleted or etc. So I'm going to go in just for inserted. For inserts, I'll get the full document each time anyway. So if I also had like update here, then for the insert, I would get the full document, like a new document. But for the update, I would only get those fields that had changed. So I'm not going to be worried about updates. I'm just going to turn on full document anyway. Doesn't matter. And my event type is going to be function. So I can just write like my own JavaScript function then to process this. Simply like handle AWS stream. And then this is where I kind of write my function to deal with it. So the comments here give you a lot of information about what's going on, and different things you can do. Like we have documentation here on kind of change events, and so it's showing you here is a document that this function, so my function I'm writing here, this change event is going to get, this is what that change event is going to consist of. So the operation type, so that's going to be whether it's an insert, a delete, an update, a rename, etc. If I've asked it for the full document, then that's where I'll get the full document. NS is namespace, so that's going to be like what database it's triggered, what triggered it, and what collection it was triggered on. 2 will be there if it's a rename, so these things may change, so that's like where it came from, where it's going to. Document key, so that's going to be the ID for the document that either was inserted, renamed, deleted, etc. A description of what happened. So, if I'm not getting the full document, if it is an update or it's delete, whatever, then I'm going to get this updated fields. It's going to tell me then that these are the fields that change in the document. Cluster time is interesting. That is the time in the op log that this event occurred. So the op log is how we keep all of the nodes in our cluster in sync, like an operations log. And this will like detail in here when this event occurred according to the op log. And then these last two, only get sent if this event is part of a multiple document transaction. So this is your transaction number, and this is the session ID for the multiple document transaction. So you'll not always get those ones. But this kind of shows you get like a lot of information coming through on any kind of trigger. We're really only interested in this kind of full document because that's what we want to send to Kinesis. I've set it up so that if we look at my settings here, that it's only going to do inserts. So I'm basically going, right, okay, anytime there is a new document inserted into my collection, I want to send that whole document to Kinesis. I want to like put the whole thing into my Firehose. So I'm going to just be looking really for this part of this change event that's coming through. So I'm going to not make you watch me write it all out in the browser because this editor is a little bit naff. I'm going to switch to like my actual editor to write it. What I would say is we are aware that developing locally and then having to like copy paste back into the browser editor is not great. There is this kind of suggestion on the forums that I've already upvoted. I hope other people upvote as well to enable kind of local development tooling. So similar to AWS SAM. So you folks already have it. We need it, but the ability to like edit functions locally rather than, as you're going to see in a minute, I'm going to like edit it in VS Code and then have to copy and paste it back into this function editor. But there is a suggestion being made to kind of have it so you can run these locally, test them locally, etc. It's just not quite there yet. So let's do my switch over to my editor. So every function, as we saw here, is going to start with this exports. So I'm just going to do like exports equals function, and it's going to receive an event. And then I need to get a reference to that AWS service I created. So I'm just going to go like, I should mention as well, I had a little accident last night. I was washing a kitchen knife and I've sliced a chunk out of the top of my finger. So any typos that we see today is mostly because of that. And I keep fiddling with the plaster as well, which I shouldn't. So I do apologize if like, I've got horrendous typing skills today, but every time I'm trying my best not to use my like middle finger anytime I'm typing, and it's not working out the best. So, okay, AWS service, and then we've got this like context object, which is something that's like global in all of our realm functions that allows me to access different services. So I'm going to do like, in my context services, and then like I give it the name I gave that service. I can't remember what I called it, but I'm just gonna like pretend it was AWS Kinesis. I think it was just maybe like AWS. And then once I have access to that service, then I can like start calling things on it. So I'm just gonna wrap this in like a try. So I have this AWS service I've just defined, and I know on that it's gonna have a Kinesis method, and Kinesis is gonna have this put record. And then put record is going to take an object. So the first thing it's going to want is some data. And that data is going to be the document that's just been inserted. So I need to convert it into a JSON string to send it to Kinesis. So I'm going to do like JSON stringify, yeah. And then I need to get that full document, which I know was just called full document on my event. Remember we saw in the here. So that's my full event we're getting through, and it's the full document is what I need off that. So I'm going to just pass it into as the data to Kinesis, and then I need to tell it what stream, which I think is capital N, I want to send it to, which I'm just going to call realm, and then it also needs a partition key, which I could have a function to generate this, but I'm just going to hard code it as a string 1 at the minute. So that's going to try to put this document into my Kinesis stream, and then I need to check to see like, let's grab my response, and I'm just going to return that response. And then just to be kind of, just in case, I'm going to catch any error that comes back. And I'm going to just log that out so I can see it. So like this is the full kind of code that we'd have for receiving, or sorry, for a trigger. So this like is just taking any document that we get via, or sorry, any document that's been inserted into that collection, and then it's going to be using this AWS service to send that to Kinesis. So it's not a lot of code, but it is something that people have to do a lot. You know, it's a fairly common kind of pattern. So we have actually a easier way to do it. I don't know if you spotted it whenever I was doing it here, but it's like select a like function or event bridge. So event bridge is, well, actually, I'm going to pass it over now to Andrew, who's going to take you through kind of all the event bridge stuff. So I'll let Andrew take over the screen sharing.
Thanks for reminding me to do that.
And while Andrew's taking over, I want to make a call out to Mo. Mo's very much an events bridge champion, so I can tell he's very excited right now.
Yeah. Okay. So as Aaron said, we have the ability to add various external services, and one of the ones we can add is AWS. And setting up the AWS service is very simple. All you really need is the access key and the private key from your account. And then the private key, we have something called secrets. So within the Realm UI, we have values, which in general are things, for example, I have my AWS region as East 1. But then we also have secrets, which, as you'd expect, you can't actually view what's in there. So when we create the AWS service, it actually creates a new secret, which is your private key. So I'm not going to type those in here. So you have the config. So now we've effectively connected it to our AWS account, but we don't have access to any of the AWS services yet. Because in Realm, basically you're not allowed to do anything unless you've given permission. So you can't get it data, a user can't get it data unless they've been given permission, etc. So in this case, we're going to create a new rule called Kinesis. And Kinesis, the actions, not surprisingly, it's going to be the Kinesis service. You can control which operations you can do, but here you're going to keep it simple and just make it so that you can access any of those services. And then when I hit save, so it gets applied. And you may remember that when Aaron was saving stuff, it was asking you to confirm that you want to deploy it and giving you a summary of the changes. I'm a bit too impatient for that, so that's something you can disable, and so I always disable that, so when I save, it's actually deployed straight away.
I make too many silly errors. I really need to get that prompt that comes up to allow me to kind of like view the actual the config before I do that, or I just know I would end up like wiping half of my work or something with a bad deploy.
It's okay, Aaron. You can blame it on your hurt finger.
Yeah. I don't know how long I can get away for that for though. So
Well, people talk about fat fingers. Yours have got a bit thinner, so you should actually be getting better.
Well, the good thing is that like it's kind of good and bad because it was a really sharp knife. So like the one little slip and I cut my finger pretty badly, but because it was really sharp, it made a really smooth, like straight cut. So it's actually healing pretty well as well. So it's like, you know, swings and roundabouts. But
yeah. Okay. And so now I'll go to the AWS console. So I'm not going to go straight into the event bridge configuration because in the event bridge configuration, I actually want to send events to Kinesis. So I'm going to set up my data streams and delivery streams first, and sort of Rob demoed this better than I can. So I'll just quickly create them here. So we want a data stream, which we can name it anything we like. I'm a cheapskate, so I'm not going to pay for more than a shard, because that's fine for this. That should be up there in a second. Okay, so now we've got that, and now I want to create my delivery stream. And so the delivery stream is going to use the data stream I've just created. And so what's happening with the delivery stream, we've got the source, where the source is going to be EventBridge. So from Realm, we're going to send our events to EventBridge, and then EventBridge is going to send them to our Firehose delivery stream. And then we'll have the destination, which in this case, we're going to send it back to Realm again. So the source of the data, as I say, we're going to use our data stream that we've just created. So you can transform the events within the Kinesis data Firehose, but I'm not going to do that here. We're just going to pass them straight through. And this is where we get a bit of MongoDB specific stuff, because for the destination, I want it to be to send it to MongoDB. And so MongoDB is one of the partner providers that you can set up in here. And here now, it's quite nice that the diagram actually updates, that you can see that now the destination for this data is going to be the MongoDB cloud, and it's actually going to be a webhook in MongoDB Realm. And then we have we're also going to send any errors, as well as we're going to send copies of the events to S3, so that we've got a backup of them there. We haven't talked about the webhooks yet, but I'm quickly going to just cheat and take a copy of it. So Aaron will cover more, but you create the webhooks under a HTTP service, and so we've got one here. So all I'm going to do at the moment is go to the settings, and I want to copy that webhook URL. So like I say, that's jumping ahead a bit.
Yeah, I'll take everybody through like the actual code and stuff there. So don't worry about like I know it's very quick that Andrew went through it, but we will get a chance to look at that in more depth in just a moment.
Yeah.
Great, and let me hop in here real quick, Aaron and Andrew. For those who have recently joined the stream, we're here with MongoDB. And we're talking a little bit about their MongoDB product Realms and how they're using that to connect up to AWS Kinesis with their streams. And so that's a little bit of what we're going over today. And yeah, catching everyone up here. Andrew, you can keep on going with that.
Cool. And again, Aaron will show you the actual function, but in there to verify that the requests hitting the webhook have come from a legitimate source, we've got to include an API key in every request we send. So I'm just going to add that in here. Okay, I'm not going to do any compression or anything, and I'm going to want to send all of my data as well as any failures to the S3 bucket. And I've got one I created earlier, so there's nothing special about the S3 bucket, so I'm not going to show you there. And let's just give a prefix so I know what I'm looking at. And I'm going to create a new role. I could create some I'd created earlier, but let's create a new role to keep it simple. And okay, so now we have that. So I'm going to switch over to EventBridge. one day someone's going to explain to me why some services are named Amazon, some are AWS, and some are just no prefix. But okay, so in there, so we've got event buses. At the moment, we've only got the default one, which isn't one we're going to use. So really, you have event buses which applications can send events to. Then you have rules which will route them somewhere. And then the bit we're going to start with is the partner event source. So again, this is one of the other integrations with AWS are demonstrating. So we find MongoDB, and then it gives us the instructions. And really, the only bit of information I need from here is my AWS account ID. So I take that, and then it tells us to switch to the MongoDB UI, which I will do. And so now the way I'm going to use that is triggers. So this is where Aaron added a function, but I am going to use EventBridge instead. So let's call the trigger new sensor readings. I've probably used a different collection name to Aaron, but so I called mine sensors, inserts, updates. I want everything. And again, here I say EventBridge, and this is where I paste in that AWS account ID. And I've created all of my stuff in US East 1. And so that's all I have to do to connect the two. Now I go back to the AWS console, and it just tells me to go back to the partner source page. And you'll see that now there we have got a partner resource. So this is that trigger being the source of the data. Again, if I go back to the buses, you'll see we don't have any new buses yet. So if I go to the partner event sources, this one I just selected, and I say I want to associate it with an event bus. And so it's going to create a new event bus. And now if we go back to our event buses, we can see that we've got a new one. So the first thing I'm going to do is kick off discovery. And what discovery is doing, it's going to sample the events that are coming through this bus and figure out what the schema is. And then you can then go and look at that schema to actually see what your data looks like. So we've created that. So now we want to create some routing rules. Not going to do it for the default bus. We're going to do it for our new partner one. And you can see we've got one rule here already, and that's the sampling. Oh yeah. So this is to the schema discoverer. So that was created when I turned on the discovery. So I'm going to create a new one, and we'll call this realm.
Andrew, is there a way you could zoom in just a tad more on the browser there? It looks like the chat's having a little bit of a hard time. There we go. How's that?
So let's call that realm Howdy event bus. And then you can decide how stuff gets on there, and you can have it scheduled, or I'm going to go for based on events. And again, there's a bit added in that's customized for MongoDB, and MongoDB is one of the partner services. And so there we are. And it creates a default pattern for the documents. And so it only gets passed, it only gets routed if it matches this pattern. So this is the default one that's built in that basically says any events that's tagged for my account, and you might recognize that account ID. If you want to be more selective, you can go and edit that and just put your own queries in there. But sure. I'm happy for everything to go through.
Quick question, Andrew. So does it need to match exactly like that, or is it looking mainly for that account node of the document? Does that make sense? Could it have account and then, a separate separate thing in there, such as tags, or does it need to match exactly that pattern?
I think I'm not an expert on that, but I think it has to be an exact match.
Okay.
But with our sensor data,
just an exact match for like that pattern though. Like it can have additional fields, can't it?
Yeah. So for example, in Aaron's data, it's got a field to indicate the name of the sensor device. If you wanted to, you could include that in here to say that I only want to route sensor devices that match one of these sets of strings.
Got it. Thank you.
So I'm using my custom event bus, and so now it's where I want to send the data to. And I want to send it to my Firehose delivery streams, rather. And there's the one I created a second ago. And again, I'm going to be a bit wasteful and just let it create a new role. I don't need any tags or anything. And there you can see that now it is up and running. So I guess it's probably best, Aaron, if you cover what that the webhook is doing, and then I can actually show the stuff in action afterwards.
Yeah, so I'll take over again. So hopefully we should all be back looking at my browser. So I'm still in my Realm app that I had open before. One thing I should point out as well is I know I made a point when I was setting up the Atlas cluster of like saying, you know, a free tier and etc. It's the same for Realm. So you do have like a free, I can't remember what the bounds are, but there's a free amount of like compute runtime, data transfer requests, etc. before you start to get charged for it. But it's all detailed here. But yeah, so what I'm just...
And I guess as a general rule with the pricing is that the aim is that the free tier should get you through development, that you shouldn't have to get your credit card out while you're still building your app. It's when you go to production that you may go over the limits.
100%, yeah. But as I said, it's all listed there. You can check total usage and view docs on like what the actual pricing levels and stuff are. I built several kind of apps for it and demos and things and never came near it. So it's pretty, as Andrew said, it's pretty decent for development. Okay, so we've kind of looked at like sending the information into Kinesis in a couple different ways, one with a trigger, then with the event bus. Now we're going to look at how we get information out of Kinesis. It's probably unlikely you'll ever want to do both of these at the same time like we're doing. You know, if the information is going into MongoDB, into a collection, and then we're sending it to Kinesis, we're unlikely to want to then take the same information from Kinesis and put it back in a different collection. You know, there's much more efficient ways of doing that. We're just going to show you both here just to kind of like close that circle or close that loop, and so you can see it both as an input and as an output. But like, don't think that you always need to use both of them together. You know, it's actually highly unlikely you'll ever use both of them together. That we're just showing you how you can do both. It just so happens that rather than creating like a separate data source to show you how you do the output, it's just easier for us to use the input we've already created. So receiving things in a webhook, we're going to need another service, which is our HTTP service. So we saw before I created like this AWS service. Now I'm going to create a HTTP service, which I'm just going to call HTTP. And this actually, as well as allowing me to make requests, allows me to receive incoming requests. So I'm going to add an incoming webhook, and then it can be like Kinesis, inbound. And I have a bunch of different options here. So Andrew kind of touched on it before that with Realm, you also have a kind of authentication and rules, and you know, before you can access some of the services, then you need to grant the user specific rights, etc. And that kind of comes in here as well. So we have application level authentication. So that allows us to authenticate the user to the webhook with credentials they provide in the body of the request. You know, so if we have like individual Realm users and we want, you know, only admin users to be able to authenticate against it, you know, or we only want people to be able to call this particular webhook, you know, if they're got moderator status, et cetera, et cetera. You know, we can do that here. System, which is what I'm going to use for this, is full privileges. So, bypasses all rules, can do whatever it wants. User it allows you to execute it as a particular realm user. So realm also has, like, if I go into app users over here, this idea of users. So I can turn on different authentication providers. So I could go, okay, yep, I want to allow email password. I want to allow like Google authentication or Apple authentication, any of these like single sign-ons. And then once I've like enabled those, then people can either log in with those, or email password. We can turn on registration and like email validation, etc. And then this kind of function then will be executed as a specific user. So we can go, okay, well, it should be run as this admin user or whatever user you want. Script, then that allows us to pick which user based upon like calling a function. So we can go, okay, we want to call this function using our current on-call user. So we can have a function that looks up a different collection to find out who's currently on call, and then uses their ID to call, or their ID and access rights to call the function. But for now, I'm just going to leave it as system. I'm not going to bother login function arguments. That's fine. Here's where we've got the webhook URL. So this is what Andrew copied to put into AWS as to where it's going to send the request. The request is a post request, so that's fine. We can leave that as it is. Here we can put in like additional kind of authorization or validation we want to put into it. I'll leave that blank for now. And again, we can also do like request validation. So we can turn on payload signatures, or we can require a secret. So we're going to, okay, we'll only accept requests to this webhook, if we can verify them or if they've got the correct secret. We're not going to turn this on in this one because Amazon has their own way of sending through a verification token, and we'll look at that whenever we come to write the function. So I'm just going to leave it things as it is. I can save this. And it's going to drop me back into this function editor. So as we spoke about earlier, I'm not a huge fan of this editor, so I'm going to just drop back into VS Code and just get rid of this function, and then I can make a start on my webhook. So again, we're going to do an export function. Now this time it's not going to take an event. It's got a payload and it's got a response. So the payload is going to receive, that's that HTTP post request that's coming from Kinesis. So that's going to be our incoming request here. And then this is the response that we want to return to Kinesis. Kinesis expects a few things in response to a webhook request. So it can validate that the data was processed successfully. It doesn't want to just be like fire and forget data at a webhook. It wants to ensure that you've received the data and you've managed to perform whatever actions you need to with that data. So if we don't respond, and the documentation there will show you exactly how you need to respond. I'll type it out for you as well. But if we don't respond to that request in this specific manner that AWS or Kinesis is expecting, it will retry. And I think it retries it maybe like 4 or 5 times before it eventually will just give up, and it'll log it as an error into our S3 bucket. So we need to have the response here so that we can add a couple things to it before we return it for a request. Now, I'm not going to type out this entire function. I'm just going to copy and paste it because it's quite long. But this is for decoding base 64. The post request that we're going to receive from Kinesis is going to be a JSON string. So it's going to be a string that we're going to need to convert back into a JSON object. And in that JSON string, there's going to be a records item, which is an array. And each of the elements within that array is going to be the document that we sent into Kinesis. So the document that's come from MongoDB that we sent right at the very start, either through our trigger or through EventBridge, whatever we want to set it, whatever data we're sending into Kinesis, it's going to come back as an element in that array, but it's going to come back base64 encoded. The functions in Realm are run with Node, but because of certain restrictions, etc., it's like our own kind of interpreter that we're using. And one of the things on it is, yes, Node does have a buffer, and so you may have used buffer before to decode base64. using the buffer to do this kind of decoding is about 6 times slower than just running a decode base64 function by itself. By the time you create the buffer object, instantiate that, and then run the decode function, this runs 6 times faster. And as I mentioned, like whenever I took back over from Andrew, is Realm, one of the things that we do bill on is processing time, like CPU time, how long the function takes to execute. So these little like, anything we can do to make it faster, these little kind of enhancements, that's obviously going to cut down in your execution time, which is going to cut down in your bill. And it might not seem like a lot, like, each one's probably going to take, a few microseconds to run anyway, like each decoding. But a single request from Kinesis can contain up to 10,000 records. So having something that is 6 times slower decoding those 10,000 records, once per record, obviously adds up. So I would, and for now, I would definitely recommend that you have just a decode base64 function. That's all it's doing is that. We're not worried about buffers or anything. Okay, so let's just start adding the stuff that we're going to need into our response. So the first thing Kinesis is going to expect is it's going to expect us to return the correct content type. So let's just set this up here. So this is our response object that we're receiving here as part of this webhook. And then we're just going to tell it that it expects it to be an application JSON. So that's fine. We can add that to our response. Next thing we want to check then is our access key. So before I mentioned that you can turn on, I think it was on this screen under my settings. You can turn on like payload signatures or required secrets. Whenever Andrew was setting up his AWS config, he set a secret with AWS that it's going to send with every request. And it's going to send that secret as a header as well. So I can go into like Firehose, this is called Firehose access key. And that's going to be in my payloads that I'm receiving. And let's look at my headers. And that's going to, I'm just going to copy this so I don't get it wrong. And it's going to be this XAMZ Firehose access key. So that's like the shared secret between AWS and Realm. So we'll be able to check to see if that equals a secret that we've got stored in our Realm app. And if it does, then we can continue with the response. If not, then we can return an error. So let's just do that check first. So we'll be like if Firehose access key, and it's going to be equal to, it's going to be stored in our context again. So this is like the Realm context we used for this. No, that's not autocomplete I wanted. Context. Thank you.
Almost.
That's good. No, I mean, yeah. There we go. So context values, and then we can look in our values for our secret, which is going to be Firehose access key. I'm aware, like I might have called it something different, but we're going to switch back to them to see it all working anyway. So we're going to just have like our if statement here, and then like, if there's some mismatch between those two, then we're going to like return an error response. So we're going to do response, and we're going to do set status code. We're going to set that to a 401, which I think is like authorization required or something similar. And then we can set our response and set body on that. And here's where we can set what we're returning as our kind of JSON or stringified JSON to Kinesis. And it requires a few things. So it's going to require the request ID. So every request that we receive from as part of this Firehose is going to have a request ID, and it's going to be in the header as well. So we can look at our payloads, headers, and it's going to be like XAMZ Firehose request ID. So that's going to be like for every request, it's going to have a unique ID that we're then going to return as part of this, so that AWS knows which requests that we're talking about, make sure there's no like mismatch. And then we're going to give it a timestamp as well, which is going to be like this new date. Get time, so it's going to return like just a timestamp as a string. Oops, an error here. Yeah, so we're just going to turn that string, and then we're going to give it an error message.
This is the most important part right here. Just so everyone knows, right? If I get one more error message that says something went wrong without any more context.
Yeah, 100%. And we'll find with hopefully if we've got time as well, Andrew can show us like querying some of the errors that you receive in S3. So having things like the request IDs and having things like well-structured error messages and timestamps, so like it's really going to help whenever you actually come to look at like interrogating that data as well and finding out what went like if things went wrong and what went wrong, and helping you to kind of debug that. So so this is like our check to make sure that the request that we've received is come from AWS and it's not somebody who's just hitting that webhook with some random data. So now we know that the data is correct and we can like get the data itself. So we're going to do like const data, and it's going to be, as I said, it's going to be a JSON string. So we're going to need to convert that JSON string back into an actual object. So it's going to be under the body text. So now we've got this data, which is going to be the contents of our post request. And then we're going to have like a bunch of documents in there. So this is where we come into this like base 64 decoding, etc. So I'm going to iterate over all of the records that's in this post request. And as I said, there can be like, I think the max is 10,000. So there can be a lot of data in here. So I'm going to just map that. And I'm going to have a new function that's going to take like each record. And I need to do a little bit of transformation on it because this document that we're receiving, I said it's like each element in that array is, well, one, it's a JSON string, so I'm going to need to like convert that back into JavaScript object again, but it's also a base64 encoded JSON string, so I need to do my decode on it too. So I'm going to go record.details. There's a lot of like decoding and happening here, so I have a detail on that. They really do. And I also know as well, because we're sending it as part of like the event bus, there's other information that we send as part of that too. So, we're saying like that full document, but it's going to have, as Andrew said, it's going to have like some account details and other things at the root of that dictionary or root of that object. So, and I'm really not interested in those right now. I just want to get the actual document that's being sent. So I can do detail.full document. And that's just going to give me the actual like document that we sent into, or the only bit we're really interested in. We're not interested in all the metadata around that. We just want to get the actual document as it was whenever it came out of MongoDB. Okay, so, I've missed I should give my variable a name here. Let's call this document. Okay, so we're going to have this, now we're going to have a array of documents, and each element in that is going to be this, at the moment we're not returning anything, but we've got this document, which is our base64 decoded and JSON parsed element from Kinesis. So I need to return this, but I want to make a small modification to it before I do. So I'm just going to use the spread operator to like expand that document. And then the change I'm going to make is the ID. So everybody thinks of MongoDB as like a JSON database, which is close. It's not actually JSON, it's BSON. So instead of like JavaScript, it's binary. And the only real difference there is we have a couple of different data types that are not available in JSON. So because this has been a JSON, it's been like converted to a JSON string. One of the data types that we support that JSON doesn't is an object ID, and that's all of the IDs in it. Well, if you don't supply an ID yourself to a document in MongoDB, then it will automatically get assigned a object ID, and those object IDs are a object, funnily enough. So because that's a data type that's not supported by just regular JSON, it's going to get converted into a string. So here, before I return this document, I want to turn that back into a JSON object ID. Because at the moment, if I did like any kind of lookup, oops, these autocompletes are really bad today. If I did like What's going on, my editor?
Object.
Yeah. So if I did like any kind of lookups on this at the moment, because this ID on the document is actually a string, it's not going to find a matching document. A string does not match an object ID, because one's a type of object ID and one's a type of string. So even if this is going to have the same kind of UID for that object, it's going to be a string. It's not going to be an object ID. So I need to convert it back into that. So using the spread operator, I can expand that full dictionary and then just override just the ID, which is what I want to change back into an object ID. So I can do that here. Go to return that. So I've got this documents is now an array of all of these. And at this point, I could just do an update many, actually in this loop, I could have just done this as a loop and just did an upsert for each one. So an upsert is like an update and an insert. So it's going to check to see if there's a matching document with this object ID, and if there is, it's going to update it. And the reason for that is in case there was a problem with one of the webhooks, we didn't return the correct information to AWS in time. And then AWS tries to replay that later on. We don't want to create duplicate records. So instead, we'll just update the record that exists with the matching ID. But so I could just do it as an individual upsert for each of these documents. But because it can be 10,000 of them, that's not going to be very efficient. So instead, I'm going to do a bulk up. So I'm going to do I'm going to first of all create a new bulk operation. So bulk up is I'm going to need to get another service. So this time the context services, and the service I'm going to need to get is my MongoDB Atlas. MongoDB Atlas. So this is allow me to query or run queries against my Atlas cluster directly from in my Realm function. I'm going to give it I can't remember what I called the database. I think it was monitors. And in there, I'm going to give it my collection, which just call it Firehose. And then I need to create initialize. This is where my spelling goes wrong. Initialized ordered bulk up. See, that one I could really use the autocomplete on. Come on. I need it for weird things I don't need it for, and that one I could really use it. But yeah, so here this bulk up is going to be a reference to this. I've created a new ordered bulk up. So that again, I could have an unordered bulk up, and that would just rather than trying to run them sequentially, it would just try to run some in parallel. I'm going to use an ordered bulk up, so they're all applied in the order I give it. So now I've got this new bulk operation I can use. Then I can start adding the documents to it. So I'm going to just loop over my documents. I'll do a for each on that array, and then I'll have a document, and then I can just do something with that document. So now my bulk ops I have here. First of all, as I said, I want to do a find. So in case there is a matching document already, and that's find is going to look on the ID, underscore ID, and it's going to use that document underscore ID that I've already converted back into a object ID. So I'm going to look up to see if there is an existing one. Then I'm going to tell it that this is an upsert. So if this doesn't find one, it's not going to just fail. It's going to do an insert instead. So it's update or insert. And then I'm going to call this update one. And in the update one, then I need to replace that document I've just received. So I'm going to tell it I want to replace. Oops. I'm going to replace the full document. So I'm going to replace the root. And then I'm going to tell it what I want to replace. So I want to tell it that with a new root equal to document. So if it finds this matching document, it's just going to completely replace the whole thing with this document that's come through from Kinesis. And then this isn't actually going to run anything just yet. I'm just going through and adding all of these operations to this bulk operation, but I've not actually executed it. So I can then do, my bulk, or weird autocomplete bulk up. Thank you. I'm just going to execute it. So that's where it's finally going to call all of those operations. So it might be like, depending on the size of the request that's come through, it could be like 1 or 2 operations, could be 10,000 operations, you know, but this is going to be much more efficient doing it this way than just like calling an update 1 in a loop without attaching it to this bulk op. So, and then once it executes, I probably want to check to see, like, well, I need to check if it's been successful. So the first function is going to call will be on success. This is the point that I want to tell Kinesis that everything's gone okay. You know, so first thing is I'm going to do like 200, HTTP state is 200. You know, everything's okay, we're all good. And then I need to send like a response body as well. So it's not enough just to send the 200 okay. I also have to send some specific information to Kinesis to let it know that, you know, it's completed successfully. So again, I'm going to just do stringify, and it's the same error, or sorry, same data we have here, except now it doesn't need to have this error message. It just needs to have the request ID and my timestamp. So I just copy and paste those from there. I probably also want to put in here, you know, just in case it didn't complete successfully, I want to have some kind of like error check. So let's do another function that's going to receive an error. And if I get an error, then, well, I'm going to do the same stuff again, but instead of returning a 200, okay, I'm going to return a 500 server error. I still need to return a request ID. I still need to return a timestamp, but again, I can now attach this error message, and that's just going to be the error object that I received in response to my bulk op. So let's just run through this one more time, and then Andrew will take over and show you all actually working. So first of all, Kinesis has to have certain things in the response. One is a content type, which has to be application JSON. We're setting that here. Then we need to check to ensure that the request actually has come from Kinesis, that we're not just accepting random data from anybody just because they know the URL for a webhook. So we get the access key from Kinesis, and then we compare that access key to our own access key that we get stored in a secret in Realm. If those things match, we parse the body of our post request that we received back into a JavaScript object. Then we iterate over the records element in that object. And each of those records is, again, going to be a JSON string, so you convert that back into an object, but it's also going to be base64 encoded. So we're going to decode it first. And then that object has a bunch of different data on it. And the thing that we're interested in is this full document. So we're just going to ignore all of our meta information and just assign document equals full document. We're going to return a document, but we're going to first convert the string ID back into an object ID so we can use it for our lookup later on. Then we create a bulk op. So we have this bulk operation. We're going to use our MongoDB Atlas service. So it's going to allow us to run queries against our cluster directly from inside our function. We tell what database we're running on, what collection, and then we have to attach our different queries onto our bulk operation. So for each of the documents that we return here that we've got from our records, we're then going to do a find. We're going to try and match up the IDs. If we can find it, great. We're going to do an update. If we can't find it, we're going to do an insert, and then we're going to do this replace root. So if there's no root to replace, we're doing an insert. That's fine. That's still going to work. It's going to do it as a regular insert. If it does find a match, we're doing an update, and it's going to replace that entire document with this new document that's come through. And finally, we execute that bulk operation. So we run through and run all of these different queries. And then if it completes successfully, we're going to tell Kinesis, hey, here's a 200, everything's okay. And then we're going to tell it this is the request that we just processed to make sure that we're not like saying, hey, everything's okay, and we've got some race condition that we've actually processed a completely different request. No, this is the request that we just processed. Here's the 200 for it. Here's the timestamp that you can put in the logs as well. If for whatever reason this bulk operation is not able to execute, say, for example, I don't have the correct authorization to access this database, whatever it could be, then it's going to return 500, so server error. And then we're going to set this response body, so again, tell what request I'm talking about, when did it occur, and then also our error message, which then whenever we're checking our error logs in S3 will really help us identify the problem.
Aaron, we had a quick
Hopefully
question.
that all makes sense. Yeah, go for it.
In the chats where we were all talking about it. I think you did hit it actually. So on line 28, I think people were expecting, JSON.object ID, but we see here like the bison.object ID. Could you review that for the chat a little bit once more?
Sure. So JSON obviously is, JavaScript object notation, which everybody does assume that MongoDB is a JSON data store, because most of the time you're working with it, the really common stacks, your MER and your mean, etc. You're passing JSON back and forward. 90% of the time you're working with data that's coming out of MongoDB, whether it be via Mongoose or via one of our drivers or whatever else, the data you're getting back is going to be a JavaScript object. But JavaScript objects, they only have a very limited number of data types that they support. So we actually don't store it as JSON, we store it as bison. It's got implications for how, obviously it's much faster for us to do lookups, etc. There's lots of really stuff that is way beyond my comprehension on the actual database side of it and how we use bison to store it and how it helps us do really fast queries. But the bit I do understand is that the bison has additional object types that are not available to JavaScript, to JSON. And one of those object types is this object ID. So in pretty much all of our drivers, whether it be like our Node driver or our Python driver or Go driver, they'll all have this bison library as well. I think for most of them, you can actually install it just by itself, or sometimes you can bundle with it. And this is essentially a library of kind of helper functions to work with the bison data type. Now, because I'm doing it in a realm function, both this JSON and bison objects are global. They're available to be used anywhere. I don't need to import it or anything like that. It's just there for me to use because you need to use it so much, it's so common. So this bison object, one of the methods it has on it is this object ID. An object ID takes a string, which will be the UUID of that ID, and it then convert that back into an object ID object. So whenever we're converting bison object IDs into JSON, because JSON doesn't support that object type, they just get decoded into string. So what would be like a object ID, with a whatever ID, whenever we convert that into JSON, it just becomes that string. And obviously those two things, if we're doing an equality, like a find, we're doing a lookup against them, well, that string is not equal to that object.
Got it.
So this find's going to fail. So here no problem. So here's why I convert it back into an object ID. So that compares this lookup here, they're going to be the same thing. Now that's only the case if you're having MongoDB set the IDs for you automatically. If you set your own IDs, then you can specify whatever you want in there. You can specify a string, and sometimes I think that's actually really useful. You might have your own identifier. I could be having something in here that's just a simple increment, and then based on the request ID, that's going to be pretty unique. And then that means I could then, go back from just with the ID, be able to tell what Kinesis request it came from. Things like that. So a lot of time we find customers will set their own IDs for things, but in this instance, I'm just using the built-in object ID. So I then have to convert that string back into an object ID if I want to do any kind of lookup or comparison with it.
Cool. And I guess there's one more follow-up question here before Rob does a quick recap. Boneless Ops is asking, so can I set it to be a key from a different data store or something else?
Yeah, 100%. Yeah, you can set the ID to be whatever you want. The object ID that we set, so if you don't provide an ID, then MongoDB will automatically set it to an object ID. And actually, they're pretty useful because they just look like a random string of characters, but the way in which it's broken down is they are actually sequential. So you can use the MongoDB object IDs and go, okay, give me every document between this ID and this ID, and it will return all matching documents. So I can't remember the actual structure of it, but they do have a random element to them, but they also are also sequential because they do conversion on a timestamp too. So you can like do lookups with lesser than and greater than IDs, just using the built-in object ID. But yeah, you don't have to use them. You can set it to be whatever string you want it to be.
Great.
Cool. So I think that was. Do you say Rob wants to do a recap?
Let's do a quick recap. So
Sure.
for everyone who just joined, initially I started in having a conversation around streaming data, Amazon's offerings, AWS offerings for streaming with Amazon Kinesis, and how you can integrate with MongoDB. And Andrew and Aaron have gone through their blog of using MongoDB webhooks with Amazon Kinesis and Kinesis Firehose, leveraging EventBridge for easy integration as well. So right now we're going to be reviewing what we talked about. Andrew, Aaron?
Yeah. So Andrew, do you want to take over the screen sharing then and run through the actual kind of end to end for people?
Sure. Let me do that.
While he's doing that, I will have to say that the handoff between you two, like with the screen sharing, is like flawless. I hope I don't jinx it, but like the fact that you're like, you type up all this code and be like, all right, I'm going to pass off to Andrew, he's going to run it, and like the fact that you're able to do that and no mistakes so far is impressive. I know, right? You still got like 20 more minutes, 20-ish more minutes. So let's hope I didn't jinx it.
Yeah. So what we've been doing is we've kind of gone full circle. We've got the database trigger that has sent that has detected that a new sensor reading that's been added to the collection. That sends an event to the event bus, which sends it to Kinesis, which then via the webhook we've just seen sends it right back at Realm and then stores it in the Atlas database again. And sort of while you weren't looking, I just set some traffic up on my instance, and all I'm doing is just every tenth of a second I'm sending in a new sensor document. And as you can see, that's generating some traffic over on the Kinesis side, and something that just to prove that it's genuine. When I typed in the password initially, I put the wrong password in, so we got the error. So this is just showing that the webhook is correctly checking that the API key matches what we've got within the secret on the Realm side. And then if I was writing them to a collection called Firehose, and so you can just see that, yeah, those documents are making it all the way from the sensor collection into the Firehose collection. There's one other thing that we wanted to show you, just to check, Rob, Braden, have we got another 10 minutes?
Yeah, we, you probably have about 20 minutes, Andrew.
Okay, perfect. Yeah, so there's one other MongoDB service I wanted to show you. So as I mentioned, we are sending a copy of all of the documents as well as any errors to an S3 bucket.
And I noticed the temperature, it said 25 degrees. Is that Celsius or Fahrenheit? That's a very important question.
I'm familiar in Celsius. Okay, so we were writing it to the Howdy bucket. And so in there we've got two folders, one that's got the documents, the other that's got the errors. And then within the documents folder, we have a folder for each month, and then within there we have a folder for each day in the month, etc. So obviously, and then eventually at the bottom you actually get to the it's even more. It always gets me that you have to put a slash at the end of paths with the CLI, and then eventually all the way down at the bottom you get to the log files, and then all of the documents are embedded in those log files. So they're obviously there, but can be a bit tedious to break through them. So we've got another service in MongoDB called MongoDB Data Lake, and what this does is it allows us to actually treat an S3 bucket as almost like a storage engine for MongoDB. And so you can use the MongoDB query language to actually build queries up looking at your S3 data. And so I quickly wanted to show how we create one of those. So we're going to configure a new data lake. And let's call it Sensor Lake. As always, I'm going to just create a new role. And so if we want to create a new role, so the wizard for the data lake is quite nice because it steps you through exactly what you need to do. And so here it's giving us an incantation to run through the AWS CLI. So if I just take that data. This is it. This is an old version I had, but that's so I'm not going to explain everything in here, but the key thing is it's giving you everything you need. And then it gives us the so I'm going to give this, because I've created previous roles, I'm going to give it a fairly random role name so that it doesn't complain about a duplicate. So I just run that, giving it the config file I just created, and then we want to take a note of the ARN, and then that's the information that the data lake needs to be able to connect to S3, or to have permission to connect. Okay, and our bucket name is realm kinesis. Oh, do I have it? No. Let's check
This
again.
is a good part for me, like not doing the actual demos. I could just be like, yeah, I think it was something close to this. Doesn't really matter. This is where Andrew has to be a lot more precise than I was. He needs to actually know what was the real things that I used for naming everything, rather than just like writing something different each time.
Yeah. You're not saying that your code doesn't run, are you, Darren?
Evidence probably points to no, to be honest.
Okay, and so right, so now we set up the IAM role, and again, I'm not paying too much attention to here to this, because the key is that the wizard is going to give you all of the incantations you need, so you don't have to worry about it. Okay, let's process that. And so give it a second, because sometimes, yeah, it'll almost always seems to happen that there's a slight delay between when the CLI believes it's granted the permissions and when you actually have them. Okay, and so now we have
Eventual consistency.
Yeah. So we'll connect to it. And the nice thing is that if you've used the MongoDB and the MongoDB shell, you're going to recognize this because it's the exact same thing. So yeah. So let's just and the database name. Oops, shouldn't have done that. No, hold on, let me go. So again, you just use your username. The database name is the realm Mises Howdy. I've got to put the wrong password in, so I'll have to do it again.
We are doing a really good job of like not displaying any secrets on stream though, so well done with that.
Yeah, as you could tell from the number of keystrokes, it's an extremely secure password. And just as if you were, so we've now connected the Mongo shell to the data lake, but now it's going to be just as if we were connected to a MongoDB server or to Atlas. And so we've got two collections in there, one with the docs and one with the errors. So we can now query and generate whatever, run whatever queries we want. So for example, let's just see how many documents we've got, how many JSON documents are in there. So just over 16,000. We can find a random sensor reading. So we've got one there, and you can see there's a time field, and also within the detail.full document, we've got a temperature. So we could do let's do a find where the detail dots full document dot temperature is greater than 25 degrees Celsius. And I want to see the latest one, so we'll sort it based on, if you see there's a time attribute there, so time and -1 means it's a reverse sort. We only want to see the latest one, so let's limit that to 1 and pretty print it. And if you've used MongoDB in the past, you'll realize that that wasn't exactly speedy with it coming back from the results. And that's to be expected because this is actually querying that data in S3. It hasn't loaded all of that data into MongoDB and then run the query in MongoDB. It's actually running it in S3. So it's never going to have the performance of if it's actually data that's stored in MongoDB. And so we get that data. And if we look at the collections again, we could do the same things with the errors. So here I just want to look at the most recent error. Actually, let me find one just so I know what to sort on. Yeah, and that's pretty. And so that will give us and we could do any other filters we wanted, etc. Oh, I've done something wrong there. Wrong. Sort.
You're missing a curly bracket after the -1.
Sort, yeah. Good catch. And so this is going to give us the most recent error. And you can see in there, it's a code 401, which means sort of that it was not authorized. And the reason for that is because I was using the wrong API key. So
you can see as well, like sorry to interrupt you, but like the attempts made there is like it did try like 5 times with that request. Depending upon what status code you send back, some of them will cause it to just fail immediately and not reattempt. But the 401, it'll keep retrying. I think maybe a 500 just tells it like, no, there's something seriously wrong, don't retry. I can't remember the actual status codes, but there are some that you can send. I saw in the cases documentation to tell it like this is a non-recoverable error.
Yeah, cool. And so that's the data lake.
Awesome. So just confirm here that Post Ops was asking, so what is the data flow here? And I think Aaron hit a little bit. It's that it's going from Mongo to Kinesis to S3, but Aaron said here that you could split it, or you could just store the errors. So I guess for everything that we've set up from Atlas to Realms to Kinesis, what is the overall flow to kind of summarize it all up for everybody here?
Sure. So the original data is coming off a Raspberry Pi. So that's just like a Python script that's sending that data via the PyMongo Python driver directly into Atlas, so directly into MongoDB's cloud database. Then, depending upon whether we use the trigger or the event bridge, the difference is negligible between the two. But the data is then being sent from that Atlas collection into Kinesis. Kinesis then sends the data to 2 different places. It sends the data via the webhook back into Atlas, but it also saves it in the S3. If there's any errors, it also saves those in the S3 as well. So data is actually going from these into 2 separate locations, S3 and back into MongoDB again. Then what Andrew's just demonstrated is the ability to query documents in S3 directly via MongoDB. So we're using the MongoDB query language. So that data that was written from Kinesis into S3, although it never made it into Atlas, whether it be because it's an error or whatever else, you can still query that information via the MongoDB shell as well. And that's the same for any kind of data that's stored in S3. It's not just these error files. This is not something that we developed to work specifically with Kinesis or exclusively with Kinesis. This is if you have JSON or CSV files that you're storing in S3, then you can query those with MongoDB as well. But as Andrew said, it's going to be a lot slower than doing an import and loading that information into a MongoDB Atlas. But if it's for kind of cold storage, error logs or archival storage or things you're not going to be running a lot of queries on, or you're not going to be querying very often, it's obviously a lot cheaper to store that kind of data in S3 than it would be to have it hot and ready to go in Atlas.
Yeah, exactly. And a classic use case would be that you have your operational data running in MongoDB Atlas, and then once it's 6 months old, you effectively archive it to S3, but you still have the ability to query that data if you want to, but it's not something you're doing millions of times a day. So it's just the data's there for, for example, if you're looking at a blog as a product review that was done 3 years ago, it's not going to be very often that people will actually scroll all the way down and need to see it. So it's kind of for the cold data that you just want to store somewhere cheap that you're not going to access too often.
That makes sense. And then there was one other question here that's talking about, charges. And I think there's going to be some reference pages that are going to be thrown out this way. But we have a question. So how are you getting charged for this kind of setup? Is it mainly just Kinesis and S3 get/list? Yeah.
I'll let you guys answer that one on the Kinesis billing.
Yeah. Rob, you want to hop in?
Yeah. From Kinesis perspective, yes, you're charged for basically you're charged for your put payload unit. So the pricing page has a detailed layout of what to expect with that, with examples. So I just pasted that. And also with S3, of course, for anything stored in S3, there'd be a charge for that as well. So you're looking at those two, and depending on whether you leverage EventBridge will also be an additional cost.
Great.
Braden, do you have any additional items to add to that?
No, I think that about covers it. And if anyone has any other questions, everyone's been calling Aaron a wizard this whole time. So if there are any other magic related questions as well, Aaron, I think is going to be happy to answer those.
Well, I just looked up the pricing information for Realm, just so you're answering that question, because I didn't have it to hand earlier. And the price, it's based on like every compute time or requests, but it boils down to $2 per million requests. So each time like Kinesis hit that webhook, it's costing you what, 0.00002 of a dollar. So
and you get a whole load of them for free before you hit that.
Yeah, so the free, you get a million free first per month, and then your next a million after that is $2.
Yeah. And
Awesome.
in reality, sort of the vast majority of our customers using Realm sort of actually stay within the free tier. And then on the Atlas side, we've been using the M0, which is our free multi-hosted tier, and you can use that for free indefinitely. And then when you go for the larger instances, you basically pay rent for those. So for example, if you've got an M10, it's running across 3 dedicated EC2 instances, and so you're effectively paying for those resources, and then obviously a margin for the service that's running on.
Yeah, I
Awesome.
did a conference up recently where I had to spider 10 million domains to get the headers of each one, so I could start like running some queries and stuff on them. And I think it's the first time I've had to go outside of a free tier, and it's like, so a collection of 10 million records, nearly 10 gigs of data, and I think my bill is like $7 a month. So,
Wow, that's awesome.
Great. Well, I think that is the end of our stream. Aaron, Andrew, thank you very much for coming on and sharing this knowledge and this demo with us. We're going to go ahead and wrap
it's been a
things
pleasure.
up.
Really enjoyed it.
Yeah, absolutely. So we're going to go ahead and wrap things up. For those that are watching, we do have another show coming up this Wednesday at 2 p.m. Pacific time. So join us again for our next episode of Howdy Partner. Until then, Aaron and Andrew, we're going to go ahead and sign off. And as I mentioned, we have 3 ways that we like to sign off, and you get to choose. That's part of the perks of coming on the show, right? So one of them is giddy up. The other one is happy trails. And the third one is y'all come back now. So which one are you guys wanting to sign off as?
I'm going to go happy trails.
All right.
Yeah. It's got to be happy trails.
Happy trails. All right. So on a count of 3, we're going to sing some happy trails. And Ghost host Mr. AM is going to take us out with a nice outro. Okay. So 1, 2, 3. Happy trails.
Happy trails.
Happy trails.